Before Copernicus, our understanding of the universe was vastly different. People believed Earth was the center of everything. This was the geocentric model, a concept rooted in ancient observations and philosophical ideas. It placed Earth at the center, with the sun, moon, planets and stars all orbiting around it. This model was deeply ingrained in the scientific and religious thought of the time. Then came Nicolaus Copernicus, a Polish astronomer who dared to challenge this established view. He proposed a radical new concept, the heliocentric model. Copernicus placed the sun at the center of the solar system, with Earth and the other planets revolving around it. This revolutionary idea shook the foundations of science and religion. Copernicus's heliocentric model was not just a shift in perspective, it was a paradigm shift in our understanding of the cosmos. It marked a pivotal moment in the history of science, paving the way for the scientific revolution that would transform our view of the universe and our place within it. The story of Copernicus's journey to this groundbreaking idea is a testament to the power of human curiosity, the pursuit of knowledge, and the courage to challenge long-held beliefs. It is a story of scientific revolution and the enduring impact of one man's vision. Nicolaus Copernicus was born on February 19, 1473, in Toruń, Poland. His family was prosperous, engaged in copper trading, which afforded him a good education. Young Nicolaus displayed an early aptitude for mathematics and astronomy, subjects that would shape his destiny. Copernicus pursued higher education at the University of Krakow, where he studied mathematics, astronomy, and astrology. He then traveled to Italy, attending the universities of Bologna, Padua, and Ferrara. During his time in Italy, he immersed himself in the works of ancient Greek astronomers, particularly the writings of Aristarchus of Samos. Aristarchus had proposed a heliocentric model centuries earlier, although his ideas had not gained widespread acceptance. Copernicus's education was not limited to the confines of the university. He also studied canon law, becoming a canon at Frombork Cathedral. This position provided him with financial security and allowed him time to pursue his astronomical observations and calculations. It was within the walls of his cathedral residence that Copernicus began to develop his groundbreaking theory. His diverse education and experiences exposed him to a wide range of intellectual traditions, shaping his critical thinking and laying the groundwork for his revolutionary ideas. For centuries, the prevailing view of the cosmos was the geocentric model, a concept deeply ingrained in both scientific and religious thought. This model placed Earth at the center of the universe, with all other celestial bodies revolving around it. The geocentric model was not purely based on religious dogma. It had roots in philosophical and observational reasoning. Ancient Greek philosophers, notably Aristotle, had developed sophisticated arguments in support of an Earth-centered universe. They observed that objects fall towards the center of the Earth, suggesting that Earth was the center of gravity for the entire universe. Furthermore, the apparent motion of the sun, moon, planets and stars across the sky seemed to support the idea of Earth as a stationary center. The stars appeared fixed in their positions, forming a backdrop against which the other celestial objects moved. The planets, however, exhibited more complex motions, sometimes appearing to move backward in their orbits, a phenomenon known as retrograde motion. To explain this, astronomers devised intricate systems of epicycles, or smaller circles within larger circles, upon which the planets were thought to move. The geocentric model, with its reliance on epicycles, became increasingly complex and cumbersome over time. Yet it remained the dominant view for centuries, supported by both scientific observation and religious doctrine. Section 4. Copernicus's revelation: the sun takes center stage. Nicolaus Copernicus, through years of meticulous observations and calculations, began to question the validity of the geocentric model. He found that the complex system of epicycles required to explain the observed planetary motions was not only unwieldy, but also inaccurate. He sought a simpler, more elegant explanation for the movements of the celestial bodies. Copernicus's breakthrough came when he considered the possibility that Earth was not in fact the center of the universe. Drawing inspiration from the ancient Greek astronomer Aristarchus of Samos, Copernicus explored the idea of a heliocentric system with the sun at the center. He realized that by placing the sun at the center, he could account for the observed motions of the planets in a much simpler and more harmonious way. In Copernicus's heliocentric model, Earth was no longer the immobile center of the universe, but rather just one of several planets orbiting the sun. He proposed that Earth rotates on its axis once daily, which explains the apparent motion of the sun and stars across the sky. Furthermore, he posited that Earth revolves around the sun once a year, which accounts for the changing seasons. This revolutionary idea challenged the long-held belief in an Earth-centered universe and laid the groundwork for a fundamental shift in our understanding of the cosmos. It was a paradigm shift that would have profound implications for science, religion, and our place in the universe. Section 5. De Revolutionibus Orbium Coelestium, a masterpiece unveiled. Copernicus hesitated to publish his revolutionary ideas, aware of the potential controversy they would spark. He spent years refining his theory, gathering more observational data and working out the mathematical details. Finally, in 1543, as he lay on his deathbed, Copernicus published his magnum opus De Revolutionibus Orbium Coelestium on the revolutions of the heavenly spheres. This groundbreaking work presented Copernicus's heliocentric model to the world. It was a comprehensive treatise on astronomy, containing detailed observations, mathematical calculations, and philosophical arguments in support of his theory. Copernicus dedicated the book to Pope Paul III, a gesture intended to mitigate potential opposition from the Catholic Church. De Revolutionibus was not an immediate bestseller. It was a complex work written in Latin, the language of scholars, and its ideas were slow to disseminate. However, the book gradually gained attention, and its impact on the scientific community would be profound. Copernicus's masterpiece challenged the very foundation of the prevailing geocentric view of the universe, setting in motion a scientific revolution that would transform our understanding of the cosmos and our place within it.